The history of computers is a fascinating journey that intertwines human ingenuity, the evolution of technology, and the quest for efficiency. It all began long before the modern electronic computer came into existence, with the earliest devices designed to aid calculations and data processing. The abacus, dating back to ancient civilizations, represents one of the first tools used for arithmetic. This simple yet effective counting device laid the groundwork for future computational devices, demonstrating humanity's desire to simplify and enhance mathematical tasks. As time progressed, the desire for more complex calculations led to the development of mechanical calculators in the 17th century. Notable figures such as Blaise Pascal and Gottfried Wilhelm Leibniz created machines that could perform basic arithmetic operations. Pascal's Pascaline, for instance, was a remarkable invention for its time, allowing users to add and subtract with greater ease than manual methods. However, these mechanical devices were limited in their capabilities and often cumbersome to operate. The 19th century marked a significant turning point in the evolution of computing with the visionary work of Charles Babbage. He conceptualized the analytical engine, a mechanical general-purpose computer that could perform any calculation given the right instructions. Although Babbage never completed his machine, his ideas laid the foundation for modern computing, introducing concepts such as the stored program and the use of punched cards for input, which would later be adopted in various forms by subsequent generations of computers. The arrival of the 20th century saw the first electronic computers emerge, driven by the need for faster and more efficient computation. Especially during World War II, the electronic numerical integrator and computer, ENIAC, was one of the first fully operational electronic general-purpose computers. Completed in 1945, it occupied an entire room and used thousands of vacuum tubes to perform calculations. ENIAC was a monumental achievement, capable of executing complex calculations at unprecedented speeds, but it was also a cumbersome machine that required extensive maintenance. Following ENIAC, the development of transistors in the late 1940s revolutionized computing technology. Transistors were smaller, more reliable, and consumed less power than vacuum tubes, paving the way for the second generation of computers. This era saw the introduction of programming languages, which made it easier for humans to communicate with machines. For instance, Fortran and COBOL emerged, allowing programmers to write instructions in a more intuitive manner, thereby expanding the accessibility of computing. The 1960s and 1970s heralded the dawn of the microprocessor, a pivotal invention that would democratize computing. The Intel 4004, released in 1971, was the first commercially available microprocessor, integrating the functions of a computer's central processing unit, CPU, onto a single chip. This innovation led to the development of personal computers, making technology accessible to the general public. Companies like Apple and IBM played crucial roles in popularizing personal computing, with the launch of the Apple II and IBM PC in the late 1970s and early 1980s, respectively. As computers became increasingly prevalent, the software industry flourished, giving rise to operating systems, applications, and the Internet. The World Wide Web, developed in the early 1990s, transformed the way people interacted with information and each other, creating a global network that connected millions of users. This era of connectivity revolutionized not only how we compute, but also how we communicate, work, and live. Today, computers are an integral part of everyday life, embedded in devices ranging from smartphones to smart home appliances. The evolution of computing continues at a rapid pace, with advancements in artificial intelligence, quantum computing, and cloud technology promising to reshape the future. The journey from simple counting tools to the complex systems we rely on today reflects humanity's relentless pursuit of knowledge and innovation, showcasing how far we have come and hinting at the limitless possibilities that lie ahead in the realm of computing.